All right, let's dive into something that trips up so many people in the networking world. You've got these two giants, right? The OSI model and the TCPIP model. They're always mentioned in the same breath, but that leads to this really nagging question. Which one was actually first?
And check this out. This question from a Reddit user just nails the confusion perfectly. Their professor is saying one thing, but then they look at the dates and, wait a minute, that doesn't make any sense. It's that classic uh-oh moment I'm sure a lot of you have had in class.
And you know what? This is such a great question. It's not just about getting dates right. It actually gets to the very heart of the history and really the philosophy behind how our internet was built and why we talk about it the way we do.
So let's settle this once and for all. What is the real story? Was the professor onto something, or do those dates tell us everything we need to know? We're going to get to the bottom of it.
Okay, let's just cut right to the chase. The simple, straightforward answer, TCP/IP was first, period. So if you've ever been told that TCP/IP was based on OSI, well, that's one of the most common myths in networking. The history on this is totally clear.
And we're not talking about a photo finish here. It wasn't even close. The core development of TCP/IP was happening for about a decade before the OSI model was officially published. This was not a close race. To really get why this happened, we have to travel back in time to what some folks call the Great Protocol War. This was this whole era, late 70s, early 80s, where brilliant people had totally different visions for how to build the future of computer networks.
And this timeline just lays it all out perfectly. You can see TCP/IP development kicking off way back in the 70s, bankrolled by the US Department of Defense for their ARPANET project. Then comes the huge day, January 1st, 1983. They literally flipped a switch, and ARPANET started using TCP/IP. That's the day many people called the birthday of the Internet. It was a whole year after that, in 1984, that the big International Standards Organization finally published the OSI model.
And this slide really gets to the core philosophy behind each one. Think of TCP/IP as the scrappy, get-it-done approach. It was built by developers in the trenches who needed to solve a very real problem, like right now. It wasn't always pretty, but man, it worked. Then you have the OSI model. That was the let's design the perfect system approach. It was created by a committee, very formal, very theoretical. It was supposed to be this beautiful universal standard for everything. The only problem? It was slow, really slow.
But hold on, that kind of begs the question, why do we even need a model in the first place? Why not just connect the computers and call it a day? Well, because without a model, networking is just total chaos.
Just look at this. On the left, that's what you get without a framework. It's a mess. Every single thing you need to do, sending the data, checking for mistakes, figuring out where it's going, it's all tangled up together. But on the right, you see the genius of the model. It takes that impossibly complex job and slices it into neat, manageable layers.
And that's all a networking model really is. It's a way of thinking, a blueprint. It says, okay, we're going to organize all this work into different layers. Each layer gets one specific job to do, and here's the golden rule. It only has to talk to the layer right above it and the layer right below it. That division of labor is what makes modern networking even possible.
So the OSI model is probably the most famous of these blueprints, and it came up with a 7-layer structure. Let's take a quick look at what they are.
And there they are, stacked from the bottom up. We start down at the hardware with layer 1, the physical layer, and we work our way all the way up to layer 7, the application layer. That's the part that we actually see and touch, like our web browser.
Okay, but how in the world are you supposed to remember all 7 of those in order? Come on. Well, network engineers have a secret weapon, mnemonics. And the all-time classic, starting from the bottom, is please do not throw sausage pizza away. Yep. Physical, data link, network, transport, session, presentation, application. It's ridiculous, I know, but trust me, it totally works.
Now, we don't need to do a deep dive on every single one, but let's hit the big ones. Layer 1, physical. That's the real-world stuff, the wires, the plugs, the actual ones and zeros flying around as electrical signals. Then you have layer 3, the network layer. This is like the internet's GPS system. It handles IP addresses and finds the best route for your data to take. Layer 4, transport, is all about quality control. Does the data need to get there perfectly? That's TCP. Or does it just need to get there fast? That's UDP. And finally, way up at layer 7, you have the application layer. That's what you're looking at right now. Your browser, your apps, all the software you actually use.
So now we have these two models. We have TCP/IP, the one that actually runs the internet,
And we have the OSI model, the one we use to learn about the internet. So how do they match up?
This chart shows it all right here. You can see the TCP/IP model is basically just a more compressed version. Its network access layer squishes the bottom two OSI layers together. The internet layer lines up perfectly with OSI's network layer. Transport is a direct match, and then TCP/IP's application layer just bundles up all the jobs of the top three OSI layers into one.
Which brings us to my favorite summary of this entire thing. It's a great line from that same online discussion. TCP/IP won the war on the ground. It's the protocol that actually powers everything. But the OSI model, it won the war for our minds. When we teach, when we learn, when we troubleshoot, we think in terms of those 7 OSI layers. It's the mental model we all use.
Okay, so if the internet doesn't actually run on OSI protocols, why do we bother? Why are we still teaching and testing people on these 7 layers from a theoretical model from the 1980s? Why does it matter?
Well, it matters for 3 huge reasons. First, it's a universal language. A network admin in Brazil can talk to one in Japan about a layer 2 problem, and they both know exactly what that means. Second, it makes fixing things so much easier. You can isolate a problem to a specific layer instead of just staring at a giant confusing mess. And third, it gives us a mental framework for understanding new technologies as they come along.
And here's the most practical part. When your internet goes out, you don't just randomly start clicking things. The pros troubleshoot from the bottom up. You check layer 1, is the cable plugged in? Then layer 2, are you connected to the Wi-Fi? Then layer 3, is your device getting an IP address? It's a logical process that saves an incredible amount of time and frustration.
So I'll leave you with this. The next time your Wi-Fi gets flaky or a web page just will not load, stop and think like a network pro for a second. Where are you going to start looking? Are you going to check the physical cable plugged into the wall? That's layer 1. Or are you going to start messing with your browser settings way up at layer 7? See? Knowing the layers gives you an actual roadmap to find the real problem.